Before I get started, just a little bit about me. So I work as a senior software developer. I've had my ham radio license since 2016. I'm pretty into digital modes, and I live in Atlantic, Canada. So with that, I'll jump right into it. So what is CATS? CATS is a modern UHF packet radio standard. It's relatively high speed, so it does 9600 baud raw, or about 4800 baud usable after forward error correction. I like to say it's APRS, but better. So APRS was amazing at the time when it was first envisioned, and even now it's still super useful. But with current technology, we can do far better. So CATS is simpler than APRS. It's also more versatile, and it's modular, allowing for easy extension of the protocol for years to come. So it can do your standard position reports, it can do messaging, including to multiple destinations, and it has much more intelligent simplex and repeater info, which I'll get into a bit later. It uses the RF spectrum much more efficiently than APRS, and the standard is entirely open. So it's got a completely open standard, and it even includes a reference implementation. So to get into the sort of technical details a little bit, so for modulation type, APRS, you might be aware, uses AFSK over FM. This made a lot of sense at the time. FM transceivers were sort of the de facto way to get onto VHF and UHF. So you'd essentially just need an APRS audio modem that can talk to your existing radio, and you'd have an APRS station. And in contrast, CATS uses raw FSK. So decades later, times have changed a little bit. We can synthesize raw FSK in the VHF and UHF range with very cheap modem chips for just a couple dollars a piece. FSK has a bunch of advantages, so it's more performant. The same amount of RF power will go further. FSK doesn't require linearity, just like FM, so it doesn't require an inefficient or expensive linear amplifier. FSK uses a more narrow signal than AFSK over FM for the same data rate. So the bottom line is that FSK modems are cheaper, lighter, more efficient, and smaller than anything we can accomplish with AFSK over FM. So CATS gets a huge advantage over APRS just from this, but it's far from the only advantage. So another thing is key up and key down times. So you're probably aware, in a busy city, the APRS frequency can become very congested, and most of this time isn't actually used for the useful data transmission. So to explain what I mean by this, if you think of the sort of typical packet timeline, what you're going to do is first you assert your PTT, and your radio is going to switch into TX mode. Then you're going to have a delay because you have to wait for your transmitter to stabilize. Then you actually send the data, and this is sort of the useful part. Then you have to deassert your PTT line. Then you have another delay because your transceiver sort of takes time to switch back into RX mode. So since APRS uses existing, voice FM transceivers, these delays can be relatively massive. So I've seen cases of hundreds of milliseconds on these delays. So if you just take APRS and you increase the data rate, you don't actually improve throughput very much. So what we have to do as well is we have to decrease these delays. So with CATS, we specify a maximum of 1 millisecond for both delays, and this is a huge improvement. So just as an example, if you imagine an average packet is, say, 30 bytes, and APRS has delays of, say, 100 milliseconds, with APRS, you're looking at 30 bytes at 1200 baud is going to be 200 milliseconds of sort of time on the air. And then with delays of 100 milliseconds, you're looking at a total of 300 milliseconds per packet. So this works out to a throughput of about 3.3 packets a second. If you run the same numbers with CATS, 30 bytes at 4800 baud usable works out to 50 milliseconds. And then you have a maximum of 1 millisecond of delays on top of that. So you're looking at, worst case scenario, 51 milliseconds a packet. So your throughput is about 19.6 packets a second. So you're looking at, a 5 to 6 times increase in your sort of carrying capacity of your channel. So you can support massively more people in large cities, or in smaller cities, you can keep the number of users the same, and you can transmit your data much more often. So here in Fredericton, it's a pretty small city. On APRS, I transmit my position every 5 minutes. On CATS, I transmit my position every second. And as CATS gets more popular, maybe I'll have to reduce that to once every 10 seconds. But it's still sort of a much higher fidelity of how often I'm transmitting my position and how accurate that's going to be on the CATS network. So another thing people ask about a lot is why 70 centimeters? So sort of the main thing is you can run full duplex with APRS. So an APRS station can be very easily sort of updated to be able to do CATS as well. you really just need to maybe upgrade your antenna to a dual bander and install a cheap diplexer, and you can run them both at the same time. So this sort of makes it so people don't have to choose between APRS and CATs. They can run both very easily, and I think this contributes greatly to sort of the willingness of people to use CATs and switch to CATs, because they don't have to make the decision of one or the other. And even in my car, I'll run APRS and CATs together. So I've got a CATs transceiver and an APRS transceiver in my trunk. Both go to a single diplexer and both go to a single antenna. The other thing is, a lot of repeaters, a lot of voice repeaters are on 2 meters. So this allows you to run CATs and voice at the same time, and they don't interfere with each other. So if you use APRS at all, if you have an APRS rig, you're probably familiar with losing reception, just for about a second every time APRS transmits. And it can be pretty annoying. It can be pretty difficult to sort of follow a conversation when this keeps happening. So you sort of avoid that entirely with CATs, just because it uses a different band. To get more into sort of what a CATs packet actually looks like, so the basic idea is one CATs packet consists of one or more whiskers, and each whisker represents a chunk of data, and there's sort of different whisker types for different types of data. And this is sort of the secret of how CATs is able to be so extremely modular, and you can add new whiskers without breaking backwards compatibility. So how does this work? The basic idea is each whisker will start with 1 byte representing its length and another byte representing its type. So if you're a node, a CATs node, and you receive a CATs packet, you'll iterate through each whisker. And if you get to a whisker that you don't recognize the type, that basically means that you aren't implemented to be able to handle that type. It might be a new type or something like that. So you can just look at the length, and you can just skip that many bytes ahead, and you can just skip over that entire whisker that you don't understand. And continue processing the packet that way. So this is sort of what makes CATs so extremely modular, is these new whisker types can be added without causing issues to existing stations. And if you look at APRS, to contrast, what often ends up happening is the comment field gets sort of overloaded to allow for backwards compatibility, but it's not very elegant, and it means that if you look at a comment field, if you don't know every option that it could be, it's possible you might think it's a text comment when it's something else. So it's not great, but it's better than nothing. But with CATs, you can keep adding whiskers, and it'll keep the protocol just as clean as if they were implemented from day one. So there's no sort of hacky trying to fit things into existing data in places that it won't cause too many issues. It's literally just, you can add a new whisker. Some things will understand it and some things won't, and there's essentially no disadvantage to not being able to understand it. It still gets digipeated properly. Everything just works fine. It's just you don't understand the new data in the new whisker. And we do other things before we put a CATs packet on the air. So we'll do data widening, interleaving, forward air correction, things like that. So we don't just put raw whiskers on the air, but this is sort of conceptually the important part, is the whiskers. So in terms of whisker types, these aren't all of them, but these are sort of the important ones. And this is also a pretty high-level overview. So whiskers can do a lot more than just what I'm outlining here. So the first one is the identification whisker. And that generally will hold your call sign, which can be up to 252 bytes long. In most cases, you probably only want it to be 6 bytes long, just like APRS. But here in Canada, special event stations can have I think it's up to like 9-character call signs. And you can't run this on APRS. It only supports up to 6 characters. With CATs, you can basically make your call sign as long as you want without any issue. So again, in most cases, you probably won't be doing this, but this sort of just keeps things very versatile. You've got an SSID, just like with APRS. In CATs, an SSID goes from 0 to 255. So it's a much larger range. You can have a lot more stations with the same call sign. And the other thing is, the SSID doesn't mean anything in CATs other than just telling different stations apart. So if you're familiar with APRS, you'll know that sort of different SSIDs mean things. Like if you have, VE9QLE-11, the 11 signifies you're a high altitude balloon. With CATs, it's literally just a different station. So, VE9QLE-11 on CATs doesn't signify anything. It could mean that I have 11 stations in total, or it could just be completely random numbers. It's essentially up to me how I want to configure my SSID, but it doesn't imply anything, the number I choose. And you also have the an icon, just like with APRS. CAT supports up to 65,000 different icons. Not all of those are sort of specified right now, but it's sort of very open, makes it very easy to keep adding icons in the future without really having to worry about a limit. You've also got your GPS whisker, which holds coordinates, altitude, heading, speed, the things you would expect to see in a GPS whisker. You've got a comment whisker. This essentially just holds a user-specified message. This one's a little bit special. If you have a long message, it can be split over multiple comment whiskers. So each whisker can only be up to 255 bytes long, but this allows us to have messages much longer than that. And in the vast majority of cases, you probably don't need this, but it opens the door for things like long form messaging over cats, long form email over cats. You could have like a cats based BBS. It's really just keep things as open as possible. Don't limit things for the sake of limiting things, even if in most cases you don't need a message that's particularly long. You've also got the route whisker, which is essentially who's repeated your packet so far, and configuration for who can repeat it in the future. And then you get your destination whisker, which holds who your packet is destined to. So it supports acknowledgements, just like with APRS. So if you send out a packet and you don't get an acknowledgement back, you can just sort of keep your trying until you do get one. So it's sort of you can handle flaky networks that way. And you can also have multiple destinations per packet. So this sort of allows you to have cats nets or sort of group chats right out of the box. And yeah, these are all pretty much just concepts that are borrowed from APRS, although they are a little bit more open-ended, a bit more versatile. But there's also a couple of new whisker types, and sort of two of the important ones, I think, are the simplex and repeater whiskers. So again, these are a new concept to cats, so there's no real APRS equivalent. Your simplex whisker holds a frequency and a modulation type, and your repeater whisker holds uplink and downlink frequencies, modulation type, tones, latitude and longitude, and a name. And there's sort of two purposes to these. So you can have a station that lists out all of the frequencies they're monitoring, both simplex and repeaters, using these whiskers. Or a fixed station could list all the available repeaters in the area. So the idea is there's enough data in these whiskers that you could program your radio from them without any sort of external source or anything. And in the future, a CATS-enabled radio could automatically program itself from the simplex and repeater whiskers. So the idea is you could go on a road trip and your radio would just sort of learn the repeaters and the simplex frequencies in use as you drive. And as you get far away, it'll just sort of forget about them. So you don't have to worry about what you're programming into your radio. You can just drive around. Your radio will learn what sort of voice repeaters are available, and then it'll forget them when you drive out of the area. So it makes road trips are a lot more convenient that way. You don't have to program all the repeaters in advance and sort of keep track of what repeaters in what area and things like that. And just to solidify whiskers a little bit more, just because they're a very core component of what makes cats so unique. These are just sort of a couple of typical examples. So if you wanted to beacon your position, just like with APRS, a packet with an identification whisker, GPS, and identification whisker, comment route and destination. And just to be clear, you can combine whiskers in whatever way you see fit. So there's a very wide variety of different use cases that are supported. But these are sort of a couple common ones you might see on the network right now. So a lot of that is mainly RF focused, but there's also an internet equivalent for cats called a FeliNet. So yeah, this is essentially the internet network for cats. The idea is you gate packets between FeliNet to and from RF. So it's very similar in form and function to APRS-IS, which is the internet network for APRS. There is an APRS-IS to FeliNet gateway running. So any cats packets that make it onto FeliNet will show up on
Your audio dropped out.
The other thing is that APRS is more limited than cats, so there's a bit of a loss of fidelity translating between FeliNet and APRS. It's not huge in most cases. Like there are valid cats packets that aren't entirely representable on APRS. So when you convert between the two, you do lose a bit of information there. And on the right there, I've got a screenshot from APRS.fi. So that's my car transmitting on cats, getting picked up by a cat's eye gate, transmitted to FeliNet, gated from FeliNet to APRS-IS, and then it eventually shows up on APRS.fi. So it might be a little hard to see, but I'm beaconing once per second there. And you can really see the amount of fidelity you get from that, just how close those points are to each other. So it's a very sort of accurate representation of my sort of position over time. Onto existing hardware and sort of the project status as a whole. So there's a couple of hardware that sort of exists right now. So there's the mobile transceiver. It's essentially a standalone transceiver unit designed for mobile use. It's got an internal GPS antenna, but it also supports an external GPS antenna. It can do digipeating by itself, so you could use one of these to run a digipeater. It runs off of 6 to 18 volts DC on the input. You program it over USB, and the hardware and software are completely open source. So I run one of these in my car along with an APRS transceiver, and that's essentially how I do my CATs and APRS in my car. At my home, I have an iGate hat. So the idea is you mount that on a Raspberry Pi. It'll transmit and receive, so it'll digipeat, but it'll also gate to and from FeliNet. And then finally, sort of as the sort of lowest barrier to entry is the SDR iGate. So if you have an SDR already, an RTL SDR, you can run one of these. Just basically as an RX-only CATS iGate. So this will gate to FeliNet. And again, the software for this is completely open source. So in terms of future work, the big thing we're working on right now is the CATS Companion. So it's basically a handheld device for sending and receiving CATS messages. So it's got a color LCD display and a physical keyboard. And it's basically just a smartphone for CATS. So it's literally, you can just sort of send text messages and receive text messages, but instead of using the cell network, it uses CATS. So it's a very similar thing. Now, the other thing is we're working on porting CATS onto radio sons. So we've got CATS running on the DFM 17 right now, and we're working on porting it to the RS41 next. So these are sort of, some of the two most popular radio sons out there. And we've got CATS running on one, and we'll have it running on the other one fairly shortly is the plan. So contributing. CATS is very young still, so there's a lot you can do to help out. For any software developers, the main thing is just building cool software that leverages CATS or contributing to existing projects. So there's a lot to do here still. We've got low-level embedded work all the way up to high-level web dev. So sort of anywhere you're interested, there's certainly a place for you. And for everyone else, building and buying CATS devices helps out a ton. Gets the coverage and the utilization up, which is important. And spread the word. So CATS is in a usable state for the average ham. It's just a matter of getting more users on board. And that's pretty much all I had. So I'll just open it up to questions.
Okay. If you down your desktop, if you down your desktop, we'll be able to see the people as they speak to you.
And
like stop sharing, you mean?
These codes will be available to people after the presentation when Dan sends them out to people.
Say that again, Barry.
These codes that he had on there will be available in the presentation that you send out afterwards. So if they didn't catch it now, they can see the thing that you send out, and they'll be able to click on the codes to be able to get the information.
Okay. Yeah, you need to be sure you send your slides to me after the presentation here. Are there any more questions out there? How are we doing in chat, Barry?
Paul has a question. He wants to know, what do you need to purchase to get on CATS, and how much are they?
Sorry, can you repeat that?
What do you have to purchase as far as equipment to get on CATS, or what can you build, or you have to buy a kit to get on CATS, and how much is the stuff?
Yeah, so the barrier to entry is pretty low. You can run an iGate. If you have an SDR, you can basically run an iGate for free. Alternatively, you can purchase a fully built iGate board for, I think, about $30 US. Or you can buy a mobile transceiver for, I believe, $69 US. So it's a pretty low barrier to entry. It's generally cheaper than the APRS equivalents, but yeah, that's sort of what you're looking at for price.
Okay, that's everything that's in chat.
Okay, I don't see any hands up. Anybody got any questions there? Okay, Paul, go right ahead.
And he said SDR? An SDR has a wide range of meaning. I mean, I have an ICOM 7300. That's an SDR, or am I buying a $200 box, or do I
Yeah,
have to
so
solve it?
theoretically you could.
SDR is a wide range.
Yep, yeah. So the RTL SDR is sort of the one that most people are using. So it's about a $30, maybe even less than that US, but it's about $30 for a little USB dongle, and that'll do it.
Okay, Gene, go ahead.
Hey, good evening, everybody. This is Gene in glorious Killeen, Texas. What platforms can this operate on? Windows, Mac, Linux, and also can it work on like Apple iOS or Android?
Yeah, so the existing hardware, so you've got your mobile transceiver, which is sort of standalone. You can program that on, Mac, Windows, or Linux. The iGate Pi hat will run on a Raspberry Pi. So that's going to be, specific to Linux, just because that's sort of what you run on a Pi generally. And then the SDR iGate, that should run on, Windows, Mac, and Linux. As the sort of protocol matures and there's sort of more software for it, I can definitely see more in sort of the mobile space as well. But right now, those are sort of not supported very well.
Okay, thank you.
Okay. Barry, I think I see a question in chat. There may be more.
Steve Storr wants to know, can the mobile be a digipeater or is it just standalone?
Yep. So yeah, you can run the mobile transceiver as a digipeater just on its own if you want.
Okay, hey, Dave, take it away, sir.
Yeah, I'm still struggling with this whole idea that somehow or another you're going to get everybody who's running a dual band mobile FM radio in their car now is going to somehow or another be able to add the ability to send and receive FSK on 70 centimeters and do that without making a peculiar contraption out of it. And how do you convince ICOM, Yaesu, and Kenwood to essentially add this to their radios? I think this whole business of essentially going away from using an FM modulation to FSK, I think technically is great, but I just don't see how you're going to convince the whole crowd to essentially move in that direction.
Yeah, it's definitely a fair point. It's very ambitious, sort of asking that to happen. From a technical perspective, it's certainly possible to run raw FSK, implement that into an existing FM transceiver. It's really just a matter of if there's a market for it. So as CATS gets more popular and there's sort of more market pressure for the big manufacturers to sort of move to that, that from a technical perspective, that should be doable. So right now, the main thing is just, gaining popularity, making this more than just a niche thing. But once that happens, then I do believe that the big guys will sort of follow along.
Well, I mean, we can see, Kenwood put out a couple of transceivers that were specific to APRS, so I guess it's not completely out of this world. But I'm just having a hard time with that.
Yeah, it's definitely fair. Yeah, it really just depends on what the market looks like, because we do see sort of less and less APRS transceivers coming out, so it's definitely reasonable to think that it can be very difficult to sort of get them to sort of catch on with CATS, and it's really just about the sort of community support and if there's a market for it.
Okay. Steve, let's go ahead.
There's nothing inherently new about running FSK through an FM radio. We do it all the time. That's what the data port in a lot of radios is for, to be able to run FSK, which was the modulation for the old 9600 baud. So that's entirely doable.
But that's audio FSK. That's AFSK. What he's talking about is raw FSK, where you take a carrier and just move the carrier back and forth.
No, sir. 9600 baud is not AFSK. It is FSK. It is modulating that frequency. And second, we've got new radios coming out. There's a promise of a M17 dedicated radio from Connect Systems. So the market is listening to new ideas.
Okay. Any comments on that?
I'm a bit of a ringer for cats.
You're doing fine. Okay. Gene, you got your hand back up, sir.
Yeah, this is for Stefan. Could you possibly send Dan a like a signal diagram of what goes on to what components from radio to radio? You don't have to go into the technical details about what happens when it hits each processor or module, whatever you want to call them, so it can be added to this slideshow later, later this week.
Yeah, I can do that.
Thank you.
That'd be great. A block diagram would be really great on this.
Exactly, block diagram. That's what I meant to say.
You did fine. Okay. Anybody else got any questions out there?
One last thing, Dan.
Okay.
Yeah, I just want to remind everybody that tomorrow is World Amateur Radio Day. World Amateur Radio Day. So try to get on the radio, talk to somebody, and wish them a happy ham radio day. That's all.
They celebrate that in Texas too?
Yeah, we celebrate a lot of things in Texas, especially the anniversary of the Republic of Texas.
Ah, okay. All right.
And we're going back that way.
Okay. We're going to stay away from that topic right now. And with that in mind, unless somebody's got something to add, subtract, or throw away, I'm going to pull the plug here, sirs.
Thank you all for coming.